All right, yesterday we talked about vectors and we talked about a quantity that has both magnitude, which was size, and direction. And then we talked about the geometrical representation, which we talked about the directed line segment, and then P was the initial point, which was where you started with the vector. And then we talked about that also being the tail. Q is the terminal point or the tip. And then the vectors were noted as with the little arrow symbol. And we looked at vectors PQ can be noted those three different ways. And then we talked about magnitude was simply just the distance formula or how long the vector was. Did y'all have any questions about those? Okay. All right, and so I think we went through number 1 and maybe number 2 about talking about the vector. Just a quick little review. We said that the magnitude of AB could be found by taking the square root. And we did -7 minus 8 all squared plus, and that was -2 minus a -4, so -2 plus 4 all squared. I believe we did that. And then we said that was the square root of 229, which was about 15.13. And I don't know, did we do number 2? No. All right, so let's go through number 2. The magnitude for RS is going to be the square root. And we're going to say 5 minus a -3, so 5 plus 3 or 8 squared plus 6 minus 10, which is -4 squared. And remember, when you're putting this in your calculator, that -4 all squared is going to be a positive 16. So you could really go ahead and do this in your head. 8 squared is what? 64 plus 16. And then you could type that in the calculator. A lot of people miss this with the negative. You can really ignore the negative if it's squared. That way you won't miss the problem. Either way, make that positive, and so you won't miss it. So that's going to be the square root of 80, which is going to be 8.94 is what I got. Okay, so for number 3, you're going to have the magnitude of vector PQ. It's going to be the square root of -9 minus 6 squared plus 10. I have 2 minus a -8 or 10 squared. So we're going to have the square root of -9 minus 6, so that's going to be -15 squared plus 10 squared. And if you put that in the calculator, and again, watch that -15, that's going to be, you can go ahead and just say positive 15 squared if you want to. Just be careful with that negative. That's going to be the square root of 325. And that's going to be 18.03. And that's your magnitude. And then question 4, magnitude of EF So we're going to have the square root, and I'm going to shorten this one a little bit. You're going to have -2 squared. Y'all can do those numbers in your head. -2, and then plus -5 all squared. And that's going to give you the square root of 29, isn't it? That's going to be 4 and 25, so 29. And then that's going to give you 15.39. Or 5.39, sorry, not 15. This vector is going to be a vector with magnitude of 0. Zero vector, a vector has magnitude of 0. In other words, you do the distance formula and you get 0. That's your 0 vector. So it has no length to it. So it could be just a point there. Okay, so now we're going to talk about parallel vectors. And that's the vectors that have the same or opposite direction, but not necessarily the same magnitude. Okay? So you have the same or opposite direction, but not necessarily the same magnitude. So in other words, you could have vector A going this way, and then vector B going something like this. And notice they do not have the same magnitude. They don't have to have the same length. However, they have the same or opposite direction. That is parallel vectors. Equivalent vectors have the same magnitude and direction. And this is probably what you thought of in geometry whenever you had parallel lines. This is A, and we'll call this one B. That's equivalent vectors. Same magnitude, so same length, same direction. And then opposite vectors, you're going to have the same magnitude or the same length, but you're going in opposite directions. And so notice how that is written. You've got A and then -A. So let's say we have A going this way and then opposite direction, but same magnitude. That would be -A. Or the best I can do. I can't draw. So that's the best you can get. So let's look at number 5. Number 5 is talking about A and E. So let's look at vector A. Vector A is going this way, and vector E is going this way. So what would we say about those vectors? Y'all look at them. They're opposite. Okay, so let's look at number 6. We've got vector I and vector F. Vector I and vector F. So what is vector I and vector F? What do y'all think? Equivalent. Very good. Okay, number 7, vector D and vector E. Those are parallel. Very good. Okay, number 8. The number 8's kind of tricky. Look at number 8 and see B and G. So B is vector B and vector G. It's down here. Well, are they parallel? Do they have the same or opposite direction? No, they don't. Are they any of these 3 that we have listed? No, so these would be none. And then C and H, what would you call those? Opposite. All right, any questions about those? All right, so the next thing we're going to look at is whether or not we can tell the types of vectors based on just having their information as far as initial point and terminal point. And we'll be able to discuss whether or not we have parallel vectors or opposite vectors or equivalent, so forth, depending on our magnitude and our direction. And notice we're going to use 2 common formulas that we already know. We're going to use the distance formula, again for magnitude, and for direction, we're going to use our slope formula. And a little bit of review for our slope formula. Again, that's y2 minus y1 over x2 minus x1. Changing y's over changing x's. There's our slope formula. So let's go ahead and find the magnitude of AB. So that's going to be the square root of 3 minus negative 7. So that's going to be 10 squared plus negative 2 minus negative 6. So that's going to be what, 4 squared? So that's going to be the square root of 116. And I'm just going to leave it like that, because we just need to tell whether or not it's the same number. So we can just leave it like that. Now let's look at the magnitude of CD. And the same thing, square root here. So we're going to say 0 minus negative 10. So that's going to be 10 squared plus 6 minus 2. Well, that's 4 squared. So that's the square root of 116 again. So we have the same magnitude. Is that okay? But now we need to do our slope. So we're going to do our slope of AB. So we're going to say 3 minus negative 7. So 3 plus 7 over negative 2 minus negative 6. So negative 2 plus 6. So we're going to get 10 over 4, which is 5/2. And then we're going to do the slope of CD. It looks like we might get the same thing, doesn't it? we're going to have 0 minus negative 10, so 10 over 6 minus 2, which is 4. So we did get the same thing. We got 5 over 2. So this means that we have the same direction, doesn't it? So same magnitude with same direction. What did that mean? What kind of vectors do we have? Equivalent. Very good. Okay, so for number 11, get my pen to write. The magnitude for AB. You should have gotten square root of 160. And if you typed in that decimal, that's okay. And then for the magnitude of CD, square root of 160 as well. And then the slope for AB. Did y'all get -3? And then the slope for CD, did y'all get +3? Okay, so what can we conclude about these vectors? Opposite? Think so? All right, so we're going to call these opposite. Okay, now we're going to talk about standard position. And you're going to have a vector in standard position when the initial side and that's the starting point. Initial side's going to be this right here. When the initial side or point of a vector is at the origin. And if the vector is in standard position and you're at the origin and you've got your terminal point is AB, then the component form, which is, this is more vocabulary, the component form of V is going to look like this. A, comma, B, with your broken parentheses there. You have to be careful because if you mean component form, then you've got to use this notation. Don't use parentheses when you mean component form, because that means something completely different. So do watch your notation here. And don't tell me, well, I meant this. I can't grade on what you meant to do. So please be careful with that. Now, when it's in this form, you can find the magnitude pretty easily. The magnitude in component form is just going to be the square root of a squared plus b squared. You're not going to have to worry about going through and finding your x1 squared minus x, or x1 minus x2 all squared and so forth. You don't have to worry about that. Component form, it's already been done. All you have to do is square a and b and take the square root. Now for the direction angle, this is where it's going to be a little bit more in depth. You're going to say tangent of theta equals b over a. And I'm going to show you why it's b over a. We're going to go back to some trig. If we draw a triangle, let's go ahead and talk about that. Of course, my drawing is perfect. It's beautiful drawing, so don't make fun of it. It's awful, I know. So let's say that theta is down here, and I wanted to find tangent of theta, and we would name our sides A, B, and C. Tangent of theta is going to be what? Opposite over, not hypotenuse. Good, you're close. It is opposite over adjacent, isn't it? Okay. So that's what's going on here. And then, do y'all remember how you solved for that theta? You had to say theta equals inverse tangent. Do y'all remember the inverse world? Inverse tangent of, and for this one it's going to be b over a or a over c, depending on how I have it drawn here. So for this one it's going to be inverse tangent of b over a, because that triangle is drawn where b would be there. All right. So you definitely need your calculators because we're going to be doing inverse tan. Now in your calculators, you need to make sure up in the top right hand corner it says DEG. And we're going to take a moment. So the first thing we're going to do on number 1 is find the magnitude. So the magnitude for R, since we're in component form, is going to be the square root 7 squared plus 24 squared. If you put that in the calculator, that's going to give you 25. Okay. Y'all can do all of that by now, right? Y'all can do. So we're going to spend more time on finding the tangent stuff. Now, let's go through the tangent. We're going to draw a triangle. Now, if I were to plot this as a point, if I were to say 724 is a point, what quadrant would that point be in? It would be first quadrant, wouldn't it? So I'm going to draw a triangle, and we stay in relation to the first quadrant. We stay in relation to the x-axis always. So we're going to draw, just like we did in Algebra 2, we're going to draw a triangle in that first quadrant, and we stay in relation to the x-axis. This is very similar to the unit circle, except for we've got different values that we're plucking off. So 7, we went over 7, and we pretended to go up 24. Is that okay? And then the angle inside here, theta, is what we're finding. Is that okay? All right. So remember, what is tangent of theta? Opposite over what? Adjacent, right? So what would tangent of this theta be? 24 over 7, right? Which is that b over a that they were talking about. So you don't have to memorize b over a. You can just do your trig with it. Now, this is tangent of theta is 24 over 7. we need just our angle measure. So this is where we're going to say inverse tangent. Hopefully it comes back to you after you see it written. 24/7. If it doesn't, it's okay. We're going to do enough of them. And this is where you put it in your calculator. So, in the calculator, you should get theta to be 73.74 degrees. And that's going to make sense because you're in standard form here. And here's your terminal side up here. So there's your angle. Now let's try number 2. Let's go through number 2. And right quick, let's go through and find the magnitude. So the magnitude of n is going to be the square root. 3 squared is 9. Plus -1 squared is 1. So the square root of 10. So we found the magnitude. That's 3 point something. Now let's look at our point. What quadrant is that going to be in? Third quadrant. Awesome. So we're going to be in the third quadrant. So we're going to go over 3 and down 1. Theta's on the inside part here. So we're going to say tangent of theta is going to be opposite over adjacent. So that becomes a positive 1/3, doesn't it? So theta is equal to inverse tangent of positive 1/3. Theta equals, and what did we get there? I don't have that value written. 18.43. Okay. Now, we've got to keep in mind, we've started at, and this is where it gets a little tricky. We're going to have to do some extra thinking. We've started at the original. We're in standard form. So we started here, and my angle has stopped down here. So that whole blue sweep there of that angle, is that 18.43? That angle's bigger than that, isn't it? Do y'all see what I'm talking about? The blue angle. So it's from here to here. So it's that whole part is the angle that we're looking for. That's the direction angle of our vectors. So we have 18.43. That's part of the angle. That's that little part. Now, what can I do to get the bigger part?
Subtract.
Not going to subtract. Add 180 to it. Because do y'all see, part of that is like 180, isn't it? And then adding on that little angle is the rest of it. So if we add 180 to that, that's going to be 198.43, isn't it? Do y'all see adding 180? Okay. Because again, here is part of the angle, and that's 180 of it. And then what we found was the rest of the angle. So we need to combine those two. Okay, let's try number 3. So the first thing we're going to do is find the magnitude of vector v. And that's going to be the square root of 8 squared, which is 64, plus 12 squared, which is 144. And you put that in your calculator. And it looks like you're going to get 14.42. Okay, now let's go through and find your angle. So we're going to say that tangent of theta is b over a. And let's plot and see where we at on this. So we would go over to the 4th quadrant, and I plot the triangle to see where we're at. And so we would do the inverse tangent of negative 12 over 8. And that's going to give us this little angle inside here. So let's get our calculators and see what value we get. And you should get negative 56.31. And so that's your angle here. But remember, we need the angle from here all the way to down here. So we need this big angle. So what we can do is say 360 minus 56.31. And that's going to give us 303.69. Okay. And so for number 4, very similar, we are going to, again, find the magnitude of k. It's going to be the square root of 121 plus 36. So we're going to get the square root of 157. And then we're going to say tangent of theta equals 6 over negative 11. And so theta itself is going to be inverse tangent of 6 over negative 11. So theta is going to be equal to 28.6. Now, let's see where we're at. We would go back and up, so we're in the 2nd quadrant. So we're right here. That's the angle that we find. Now keep in mind, here's the angle. Goodness, that yellow's, you can't see it so good. That yellow right here, that's the angle that we need. Let's swap it. Here we go. From here to here. That's what we need, is this angle here. So what we're going to have to do is take all of this, which is 180 degrees, and we're going to have to subtract 28.6. And when we do that, we're going to get 151.39. All right. Moving on to our next problem, number 5. We've got, looks like the third quadrant again for some of these that we've worked through. So again, we're going to have the square root of 4 plus 64. So we have the square root of 68. And then we're going to find, again, tangent of theta is going to be -8 over -2. So that reduces down to 4. And so really we're going to have theta equals inverse tangent of 4. And so theta is going to be equal to (75.96). And if we look, that's down here in the third quadrant, and our angle we found is here, but the angle we need is this big angle. So we're going to have to add 180 to it. So 180 plus 75.96. So we get 255.96. All right, and number 6, pretty straightforward problem. We're in the first quadrant. We have the magnitude of A. We have the square root, 14 squared plus 5 squared, and that's going to give you 14.87. And then we're going to talk about tangent of theta equals 5 over 14. So theta equals inverse tangent of 5 over 14. You can hear the kids outside. And that's going to give you 19.65. Now let's see if we need to do anything with it. You're going to go over 14 and up 5. So your triangle looks something like that, and your angle is right inside here. So you're in the first quadrant. So the angle that you find is the angle that you need, because here's your standard position, and there's where you're ending. So there's your angle. So you don't need to add or subtract anything since you're in the first quadrant. All right, so to find a vector in component form, all you have to do is subtract these x1 and x2 and then y1, y2. So to find your component form for CD, you're going to say 6 minus 3, which is going to be 3, and then 3 minus 5, which is -2. And then RS, same thing. You're going to say -2 minus 5, so -7. And then 1 minus 10 is -9. And that's your component form. And that's all the notes we're going to do. Everything else is repetitive from here.